Look at the problem 12. The general solution to the differential equation dy over dx equal x over y is y equal plus minus the square root x squared plus c. Let y equal fx be the particular solution to the differential equation with the initial condition f minus 3 equal minus the square root of 3. Which of the following is an expression for fx and the domain for which the solution is valid? Okay, this is differential equation, and in the case of problem, the result is y equal plus minus the square root x squared plus c. To find the answer, first we should find this constant c by plugging this initial point. Okay, so plug in this value, x equal minus 3, y equal minus the square root 3. So plug in, this is minus the square root 3 equal plus minus the square root 9 plus c. Apply square on both sides in this equation. 3 equal 9 plus c. C equal minus 6. Plug in this value. So y equal plus minus the square root x squared minus 6. We in the squared function, we just handle the domain of the positive domain of the inside square root. So x squared minus 6 is positive. So x is more than the square root of 6. X is less than minus the square root of 6. Considering this domain, let's this graph roughly. Oh. Let's solve this problem 12. The general solution to the differential equation. Okay, I'll capture this problem. Okay. Let's solve this problem 12. The general solution to the differential equation dy over dx equal x over y is y equal plus minus the square root of x squared plus c. Let y equal fx be the particular solution to the differential equation with the initial condition x equal minus 3, y equal minus the square root of 3. Which of the following is an expression for fx and the domain for which the solution is valid? Okay. This is a differential equation. The latter part is the result. By using this initial, we can find the constant c. So plug in this value instead of x and y. So minus the square root 3 equal plus minus the square root 9 plus c. Apply square on both sides in this equation. 3 equal 9 plus c. So c equal minus 6. Plug in this value, the above equation. Y equal plus minus the square root x squared minus 6. In this graph, we should find the domain. In the square root function, we just handle the positive part inside of the square root. So x squared minus 6 is more than 0. Then factoring method like this. X is more than the square root 6. x is less than minus the square root of 6. Considering this domain, I can draw this graph like this. This is x squared minus 6 like this. Lovely. And I can draw like this. Almost real phenomenon is continuous, so you should choose a continuous part, including initial point. Yeah, so minus 3, x part is negative, y part is negative. So the answer is this. This is y equal minus the square root of x minus 6. The domain is x is less than minus the square root of 6. So the answer is A. Okay. Look at the problem 13. By using the differential equation separable, we can solve this problem like this. 1 over 3 minus y dy dx. Apply integral on both sides like this. So, integral. You should check the numerator part. If there exists denomination, let's solve problem 13. If dy over dx equals 3 minus y, and if y equals 2 when x equals 1, then you should find y function. Let's use the separable method like this. 1 over 3 minus y dy, this is dx. Apply integral on both sides like this. Then you should check numerator part. If there exists the differentiation of the denominator like this, to match the original value number 1, you should multiply minus 1. Then the result is, if you calculate these two numbers, you can find 1. So this is dx. Okay, I can apply ln. The fundamental reason is, yeah. I explain one more time. Actually, to calculate this part, you should use the substitution integral like this. T equals 3 minus y. To find dy and dt, differentiate this equation dt equal minus dy. dy equal minus dt. So this is here. This part is here. So I can rewrite this is 1 over t minus dt. So extract minus 1 over t dt. This is minus ln t plus c. Plug in the original value, minus ln 3 minus y plus c. Okay, so This value is here. But if you formulate this method, you just check out this part. You should check this. This is whether it is the differentiation of the denominator or not. So then it is ln, just ln, 3 ln minus y. This is x plus c. Look at the problem 30. If dy over dx equals 3 minus y, and if y equals 2 when x equals 1, then you should find y function. Let's apply the separable method. This is dy over dx equals 3 minus y. Separate these variables respectively. 1 over 3 minus y dy. This is dx. Okay, the initial point x equal 1, y equal 2. Apply integral on both sides like this. This is, yeah. Take this front part. Integral 1 over 3 minus y dy. Let's use the substitution integral, yeah. So t equal 3 minus y. To change this part into dt, differentiate dt, dy. Okay, so dy minus dt. Plug in this value instead of dy. Plug in this value, 3 minus y. So I can rewrite integral 1 over t minus dt. This is extract the sign, negative sign, 1 over t dt. This is minus ln t plus c1. Plug in this value, minus ln c minus y plus c1. Okay, come back. So this is minus ln 3 minus y plus c1. This is x plus c2. So minus ln 3 minus y x plus c2 minus c1. This is just c because c is undecided. So minus ln 3 minus y x plus c. ln 3 minus y minus x minus c. So 3 minus y equal e to the power of minus x minus c. Separate this. Oh, this is just c. So because it is undecided, 3 minus y equal c times e to the power of minus x. Minus y equals c times e to the power of minus x minus 3. So y equal 3 minus c times e to the power minus x. Let's find c. Yeah, plugging this coordinate x equal 1, y equal 2. Yeah. So this is minus 1 plus. Yeah, so c equal e. So plug in this value, but yeah. Therefore, y equals 3 times e to the power of minus x, 3 minus e to the power of 1 minus x. So the answer is B. Okay. Yeah. Look at the problem 15. Okay. Which of the following the solution to the differential equation dy over dx equals 3 times y over 3 times x plus 1 with the initial condition y0 equal e for x is more than minus 1 over 3. Okay, let's solve problem. Separate these variable x, y respectively. So dy over 1 over 3 times y dy 1 over 3 times x dx. Apply integral on both sides. This is 1 over 3 ln y plus c 1. This part is take this integral 1 over 3 times x plus 1 dx. Using the substitution integral, t equals 3 times x plus 1. Follow 3 steps. This is first step. This is second step, differentiation dt, 3 times dx. dx equal 1 over 3 dt. Plug in this value instead of dx. Plug in this value instead of denominator. So integral 1 over t, 1 over 3 dt. Extract fraction 1 over 3 ln t plus c. Third step is plug in this value again. 1 over 3 ln 3 times x plus 1 plus c. C2, C2. Anything. Come back. This 1 over 3 ln 3 times x plus 1 C2. Okay. 1 over 3 ln y. 1 over 3 ln 3 times x plus 1 C2 minus C1. This is just C. So, and multiply 3 on both sides, ln y, ln 3 times x plus 1. This is 3 times c. Oh, it is just c. So ln y equal ln 3 times x plus 1 plus c. Y equal e to the power of ln 3 times x plus 1 plus c. Okay. Separate e to the power of ln 3 times x plus 1. This is e to the power of c. This is just c because e to the power of c is constant, also undecided. So y equals c times e to the power of ln 3 times x plus 1. Using the property of ln, we can exchange these two value, these two parts. So y equals c times 3 times x plus 1 ln e. This is 1. So I can rewrite y equals c times 3 times x plus 1. To find the c, I'll use the initial point x equals 0, y equals e. Plug in this value. So then e equals c. Oh, come back. Therefore, y equals e times 3 times x plus 1, 3 times e times x plus e. So the answer is B. Okay. Look at problem 16. Mm, This problem is related to the separable method. Okay. If dy over dx equal y times secant square x and y equals 7 when x equals 0, then you should find y function. Okay. So to use separable method, separate these variables respectively 1 over y dy secant square x dx. Apply integral on both sides. This is ln y plus c1. This is tangent x plus c2. Move c1 to c2. This is a c. Okay. Ln y equal tangent x plus c. Y equal e to the power of tangent x plus c. Separate e to the power of tangent x, e to the power of c. Oh, it is just c. I can rewrite y equals c times e to the power of tangent x. Let's find constant c by plugging this coordinate x equals 0, y equals 7. 7 equals c times e to the power of tangent 0. This is 0. So c times e to the power of 0, this is c. Oh, c equals 7. Come back this equation. Therefore, y equals 7 times e to the power of tangent x. So the answer is C. Look at the problem 17. If y equal fx is a solution to the differential equation, dy over dx equal e to the power of x cubed with the initial condition x equals 0, y equals 3. Which of the following is true? Okay, let's apply separable method. Dy equal e to the power of x cubed dx. Apply integral on both sides. Integral dy plus c1 integral e to the power of x cubed dx c2. Okay. It is hard for you to integral manually, so referring this example, let's apply the fundamental theorem like this. This is a x e to the power of t q dt. Yeah. So considering initial point 0, I can rewrite this is initial point 0 x e to the power of t q dt. Okay. So yeah, I can rewrite this is y plus c1 integral from 0 to x e to the power of t cubed dt plus c2. Move this constant y equal integral from 0 to x e to the power of t cubed dt c2 minus c1. This is just c. I can rewrite y equal integral from 0 to x e to the power of t cubed dt plus c. Okay, plug in this value instead of x, y. So find the constant c. This is 3. This is from 0 to 0 e to the power of t cubed dt plus c. This part is 0 because these ranges are 0. So 3 equals C. Plug in this value. Therefore, y equal integral from 0 to x e to the power of t cubed dt plus 3. So the answer is D. Thank you for listening. I'm always rooting you. Good luck.